In this video, we're going to be evaluating functions and looking at the difference quotient. In this first example, we're going to evaluate the function f of x is equal to 3x minus 5. In our function, x is our independent variable. And when we're evaluating a function, we're going to place whatever is inside the parentheses in for each independent variable in the function. In this case, we only have one independent variable. In A, we want to evaluate our function at 3, which means we're going to place 3 in everywhere our independent variable x is. So we have 3 times 3 minus 5, and 3 times 3 is equal to 9, minus 5 is equal to 4. So f of 3 is equal to 4. In B, we have f of h, which means we're going to put h in everywhere there's an x. So f of h is equal to 3h minus 5. In C, they want us to find f of 3 plus f of h, and we've already found f of 3 and we've already found f of h. So f of 3 plus f of h is 4 plus 3h minus 5. And now we can simplify this. 4 minus 5 is negative 1. So we have 3h minus 1. In D, we want f of 3 plus h. And this is different than above because above we found f of 3 plus f of h, and below we're only evaluating f at 3 plus h. So everywhere where there's an x, we're going to put 3 plus h. So f of 3 plus h is equal to 3 times 3 plus h minus 5. And now we're going to simplify this. 3 times 3 is equal to 9 plus 3h minus 5. And 9 minus 5 is equal to 4. So we have 3h plus 4. In E, we want to find f of 3 times f of h. And again, we've already found f of 3, and that was equal to 4. And f of h was equal to 3h minus 5. And when we multiply the 4 through the parentheses, we get 12h minus 20. In F, they want us to find f of h divided by f of 3. And f of h is equal to 3h minus 5 divided by f of 3, which was equal to 4. So this one is complete. There's no simplification required. In the next example, we have f of x is equal to x squared minus x minus 1. And the difference in this example than the other example, this function has the independent variable x twice in it. So in A, when we want to find f of 10, it's equal to 10 squared minus 10 minus 1, which is equal to 10 squared is 100, minus 10 minus 1 is equal to 89. In B, we want to find f of x squared, which means we're going to put an x squared in everywhere where there's an x. So we're going to have x squared squared minus x squared minus 1. And this is equal to x squared squared is x to the 4th minus x squared minus 1. In C, we want to find f of 5x, and this is equal to 5x squared minus 5x minus 1. And this is equal to 5 squared is 25. And then we have x squared minus 5x minus 1. In D, they want us to evaluate 5 times f of x. So in this example, we have 5 times f of x, which is x squared minus x minus 1. And then we can multiply the 5 through the parentheses and call it 5x squared minus 5x minus 5. In the last example, we're going to look at the difference quotient. And the function we're going to use for this example is f of x is equal to 2x squared minus x. And then they want us to find in A, f of x plus h minus f of x divided by h. And in B, they want us to find f of x minus f of a, all divided by x minus a. So for example A, we have f of x plus h, which means we're going to place x plus h in for each of the x's in our function. So we have 2 times x plus h squared minus x plus h minus f of x. So we have minus 2x squared minus x divided by h. And now the first thing I'm going to do is multiply out x plus h squared. So I have 2 times x squared plus 2xh plus h squared. And now I'm going to distribute my negative through the parentheses, minus x minus h. And I'm going to distribute the negative through the parentheses again. So I have minus 2x squared plus x, all divided by h. And this is equal to, now I'm going to multiply the 2 through the parentheses. So 2x squared plus 4xh plus 2h squared minus x minus h minus 2x squared plus x, all divided by h. And now I'm going to use a highlighter to show the things that cancel in the numerator. We have a positive x and a negative x, and we have a negative 2x squared and a positive 2x squared. And now I'm going to factor in h out of everything remaining in the numerator. So this is equal to h times 4x plus 2h minus 1, all divided by h. And the h's now cancel, and our answer is 4x plus 2h minus 1. And now in B, they want us to find f of x, which we already have, which is 2x squared minus x, minus f of a, which is 2a squared minus a, all divided by x minus a. And the first thing I'm going to do is distribute the negative through the parentheses in the numerator. So I have 2x squared minus x minus 2a squared plus a, all divided by x minus a. And now I'm going to rearrange my numerator, and I'm going to rewrite it as 2x squared minus 2a squared minus x plus a, all divided by x minus a. And now I'm going to factor a 2 out of the first two terms in the numerator. So I have 2 times x squared minus a squared. And now I'm going to rearrange the other two terms in the numerator. Instead of writing minus x plus a, I'm going to write plus a minus x. And I'm going to put that in parentheses, all divided by x minus a. And now in this parentheses we have x squared minus a squared, which we could rewrite as 2 times x minus a times x plus a. And now instead of having plus a minus x, I'm going to write that as minus x minus a, all divided by x minus a. And now in the numerator, we can factor out an x minus a. So we have x minus a times 2 times x plus a minus 1, all divided by x minus a. And when the x minus a's cancel, we're left with 2 times x plus a minus 1, which is equal to 2x plus 2a minus 1. And that's all for this video on evaluating functions and the difference quotient.